Good afternoon to everybody, and for those in other time zones, good day. This is Neil Elliott. I'm Senior Director for Research here at the American Council for an Energy Efficient Economy. Thank you so much for joining us today for this important new report that was released. We will have my colleague Ed Ryder talking about the content of the report. He was the lead author on this project and is the director of our industrial program. And we're joined by three esteemed colleagues who will be talking about an important topic that ACEEE has been working on for a number of years, beneficial electrification. And we're going to go over this report, the findings, the outline of the agenda today. I'll give you a couple of content and housekeeping, and then do some introductions. Then we'll have Ed do the findings on the report, and then have a discussion among the panelists and Ed, which I will moderate. During that time, we'll look forward to receiving questions from you. If you look at the bottom of your screen, you'll see a Q&A button, and that'll push open a window. And if you can type your questions in there, and then I will send the questions out to the attendees. There is a question about the audio. Some needs to do something about the audio. Do we know? Can you be more specific about the audio issues? While we're looking, okay, so we've got some people who seem to be having some issues on the audio. You may want to think about using the phone dial-in if the audio does not appear to be working on the web browser. So anyway, when we go to the panel discussion and the Q&A, if you have questions, please use the Q&A to send messages to us. I mentioned that we have three esteemed panelists here joining Ed. Tom Bodega from NYSERDA, Eric Massanet, who is at the University of California, Santa Barbara, and also serves on the ACEEE Research Advisory Board, and Colin McMillan from the National Renewable Energy Lab. Colin will be, he has been a frequent collaborator over the last few months with Ed and myself as we've been looking at industrial decarbonization issues. Eric Massanet is an eminently respected authority in industrial energy issues, formerly with Lawrence Berkeley Lab, Northwestern University, and is, I believe, currently the editor or the lead for the IPCC chapter on industrial issues. So it would not be possible to hold this without thanking our sponsors. I want to note that the Tilia Foundation was very generous in providing a grant to fund us, and then NYSERDA, National Grid, ComEd, Pacific Gas and Electric, and Southern California Edison all were very generous to provide the funding for this project that made the conference possibility. So with that, would like to introduce Ed Ryder. Ed joined ACEEE a little over a year ago after a distinguished career of 31 years with the Dow Chemical Company. He's a PhD chemist and has been leading our work on industrial decarbonization, and was the lead researcher on the report that he will be speaking about. And with that, I will turn it over to Ed.
Okay, Neil, thanks very much for that intro. I'd also like to thank the sponsors who not only have sponsored this work, but also provided guiding comments on the review. So definitely appreciate that very much. So industry faces an enormous challenge with this concept of industrial decarbonization. That is removing the carbon intensity and dependence of industrial production and products. This is particularly challenging as energy use is enormous for industry in the US. As this slide shows, industry accounts for a large portion of the energy use within the US, some 22%, excluding feedstocks. And out of that industry slice of the pie, if you will, on the right-hand side, you see that the heavy industry sectors, such as chemicals, refining, metals, food, etc., accounts for a large portion of that energy spend. Hence, as we think of ways to decarbonize industry and the pathways associated with it, these major sectors are a strong point of focus. So as you'll see in the report, we propose and find that electrification is one of the top ways that industry can decarbonize. It's a way that the fuel sources, energy, can be substituted in large part while using the same hardware that industry is already using. So this is a way to start on the process of decarbonization with the current installed capital. We also see that electrification can be increasingly beneficial if that electricity comes from low carbon sources, wind, solar, nuclear, etc., biofuels. And it's that dependence on the increasing amount of low carbon content within the energy sector that's one of the important things to consider for electrification. One of the large opportunities, cross-cutting opportunities in this space is process heat. Industry uses enormous quantities of energy for heat across a very wide range of temperatures. As you can see on this chart, for some of the major sectors, there are relatively low temperatures of process heat, upwards of about 100, 150 degrees. There are medium ranges, upwards of 300 degrees. And it's those two ranges where we see early opportunities for beneficial electrification. Now, the higher temperature regimes can also be accessed, but the technologies to access them are emerging, or in some cases transformative, and maybe some years away at this point. There's also, of course, opportunities in this space for other fuels to accommodate some of that really high energy range, but it's the low to the moderate ranges that are accessible today for electric technologies. So if you look at some of the electric technology options on this chart, where I've got a loosely shown by heat range, towards the top you can see is greater temperature. In the lower range, there's a wide assortment of electric technologies that can be considered, from infrared and UV microwave to pulse electric field drying, ohmic drying, radio frequency or RF also comes in some of the lower temperature ranges. In the mid ranges, one can think of hybrid and electric boilers, steam generators, and heat pumps. Heat pumps have been increasing their higher temperature capability. With some of the advanced technologies now, you can get upwards of 150, 160 degrees C. And there are suggestions to get even higher than that with specialized instrumentation and hardware. There also are some higher temperature capabilities. You can see a direct arc melting. Electroslag and plasma are in some of the higher temperature ranges, and these are just some of the capabilities or technologies that are available in that space. It's important to consider across this space also some of the areas where electric technologies have shown early application. specialized materials production, for example, radio frequency drying, surface curing. In these applications, electric technologies have provided specialized materials benefits. And it's those benefits that have driven early application of these technologies. And as you can see on the graph on the right-hand side, those can decrease the amount of drying time, for example, which is particularly important for non-energy benefits, which I'll talk about shortly. Here it is. The non-energy benefits can be the deciding factor in many cases. Sometimes the direct energy benefits aren't enough to justify the adoption of equipment. But if you combine in the non-energy benefits, which you can see are myriad on this chart, those can be the deciding factor on whether an electric technology is implemented and justified versus incumbent technology. Well, location matters. In fact, it matters a lot in this case relative to the potential of industrial clusters. If you look at where industry is clustered or concentrated, as you can see on this graph on the right-hand side, you can see that it's not homogeneous. In fact, it's concentrated in regions such as the Gulf Coast. You can see concentrated regions in Ohio, along the Ohio River, Mississippi River, and out in California as well. These clusters offer productivity, innovation, competitive, and other benefits. Hence, an early location to trial, to push the adoption of electric technologies further, could be at these industrial clusters. Well, some of the recommendations, which you'll see in the report, are shown here. We have them broken apart in several different areas. You can see for industry, the challenge here is to proactively engage on these cross-cutting opportunities, such as process heating, to push the adoption rate of these electric technologies. And while they're pushed, they'll be pushed into higher levels of scale. Scale is really important in industry, and with scale comes improved economics, improved understanding of how the technologies will be applied, and greater visibility for those technologies. You can also see that we have some recommendations here for utilities. As industry looks at using larger amounts of electricity, it'll be important that that electricity is provided 24/7 with really, really high reliability, better than 99.5% reliability. And it's also important that, of course, they become cost competitive. And as I mentioned on the first slide, that they bring an increasing amount of low carbon content to the energy supply. There are also recommendations from the policymaker perspective, which you'll see. The economics currently for some of the transformative technologies are pretty rough. Policy support will be particularly important for early adoption, for pushing that adoption to higher levels. And you can see in the report, there's a number of recommendations that are made for policymakers. So we'll come back to this discussion slide after we hear from our several other panelists, but right now I'll pass it back to Neil.
Thanks so much, Ed. So now we're going to hear from Todd and give a perspective as somebody who runs a program at the state level that is seeking to address the challenges of industrial decarbonization. Todd?
Thanks, Neil. And I want to first start off right back at you. I want to thank ACEEE for their hard work over the years on diving into research topics that are such forward thinking as this. Thank you, Ed, Andrew, and Neil for your work on this. In terms of beneficial electrification in the report, I want to touch on some strategies that we are deploying in New York on the market development side that we're trying to enable delivery of energy efficiency and clean energy solutions through financial support, education, technical information, data, just to name a few. In New York, under new efficiency New York, investments in energy and efficiency and building electrification will increase substantially in the years to come. You know, we're striving to decarbonize buildings, and we'll need a comprehensive approach to transition from natural gas and requires non-fossil fuel solutions to heat and cool businesses and homes and the industrial sector to find out solutions about beneficial electrification. And one of the key aspects of reducing industrial carbon footprint to net zero greenhouse gases is through energy efficiency. And in the report, energy efficiency is noted, and I'll quote this, as a foundational pathway and essential to pursue energy efficiency in parallel with electrification to preserve critical resources and most effectively use capital while also deploying low carbon solutions as they become commercial. We couldn't agree more on that. You know, by the first step of pursuing these solutions, not only lowers the energy costs, but it can potentially free up capital for future, investments in beneficial electrification. So in New York, we kind of look at this in terms of how can we build pipeline? How can we provide information to industrial facilities? And we've done that through conducting, engineering analysis that kind of provides the primer for technical information, with objective site-specific studies that will, best how to implement clean energy or energy efficiency technologies. And this can include low-cost, no-cost solutions and recommendations on compressed air systems, which are, considered the third utility in, industrial facilities that can find, misapplication leaks, opportunities for, for variable frequency drives to be installed. So we find that approach to be very, successful. And another approach to assist industrial firms to enhance is looking at their energy management practices at their facilities, which I think is very critical. If we target to provide financial and technical resources aimed so that they can implement a sustainable energy management practice at their facility. And we do that through assisting like an on-site energy manager and critical for the strategic energy management initiatives. And we have found for those industrial facilities that are engaged, they look at it in terms of a fuel neutral approach, natural gas, electricity, all fuels, and they can reduce their energy targets from 2 upwards to 10%. And we do that through a cohort approach. We bring various industrial facilities together. They learn, through the Plan, Do, Check, Act of strategic energy management. And together they move through the process, and it has been very successful. We're looking to go on to expand that and build on other best practices that follow, EPA guidelines, ISO 50001 ready platform, so that they can do it on a self-serve. It's this foundational piece that will help lay the groundwork for beneficial electrification. Another path in the report that, if I quote, is digitizing, control, and monitor of electric technologies. And we've seen success in that in New York through using smart data analytics in our real-time energy management program, which supports real-time energy data for facilities, central plant, and manufacturing processes, which can pinpoint inefficiencies and opportunities to justify capital improvements. And then the final aspect of what we're trying to do is, kind of showcase case studies. And through a carbon challenge where we're looking for cost-effective carbon emission reduction projects, and we'll soon be expanding that to include beneficial electrification projects with a notion that, can we showcase some early successes that will build momentum as we go forward into the future? So those are some of the strategies. It builds, the critical part, we see is, first step is energy efficiency. And maybe that will open up the opportunities to provide capital for some beneficial electrifications and technologies that aren't, potentially not ready for prime time quite yet. So with that, I will turn it over to Eric, or back to you, Neil, I should say.
Thanks, Todd. And we will now hear from Eric Massonet. So, Eric, and I believe Eric does have a couple of slides.
I do. Thank you, Neil, for the introduction. And let me join Todd in congratulating ACEEE on this, I think, really important report on a really critical class of technologies, industrial electric technologies. I think the timing of the report is really important because industrial electro technologies are a really important solution for decarbonization. And I think also that the timing is really right for this renewed focus that ACEEE is shining on them. So in this first slide, I took the liberty of summarizing and reorganizing some of the technology data within this great new report, because I wanted to highlight what I think are really two important aspects of the opportunity space that could be topics of discussion today in the Q&A. And the first is really the heterogeneity of options. So this table shows many of the options that are highlighted in the report, but it categorizes them based on their market availability and their industry applicability. And right away, we can see that there are many different electro-technology solutions. So for pretty much any industry, there are a suite of technologies that can be deployed and that can take advantage of increasing quantities of renewable energy for helping industry decarbonize. And that brings with it a lot of opportunities for a lot of industries, but also some challenges when it comes to deploying these technologies due to their heterogeneity. So from a policy perspective or utility incentive perspective, this heterogeneity also has to be addressed because if we contrast it with, for example, energy efficient motors, there were a few incentives, a few policies that could deploy those technologies across all of industries. Whereas for some electric technologies, they're very industry specific, very process specific. And so there are some challenges associated with understanding them and getting the word out and providing the right incentives that I think are worth discussing. The second aspect is that, if we look at the columns in the table, there are many options that will be important in the future for decarbonizing industry, hydrogen DRI for steel, electric cement kilns and so forth. Those are certainly worthy of more R&D investment and ramping up those investments as was highlighted in the report. But I want to call attention to the fact that there are many electric technologies that are available today and have frankly been available for quite a long time. As someone who's been studying these technologies and how they could play a role for now a couple of decades, many of these technologies we have in hand, and there are plants that are adopting them, but they certainly need a boost. And what can be done to accelerate those technologies, I think, is an important contribution of the report. But the timing is really right. So just to put into context, and maybe some broader context, why we should have this renewed focus on electro technologies. There are really, it's a confluence of factors occurring on the supply side and then, within the industry sector itself. So on the supply side, if you look to the left-hand side of the graph, I'm showing you the blueprint for decarbonizing the global power sector from the IEA, their latest Energy Technology Perspectives report. This is the beyond 2 degrees scenario, which is consistent with the goals of the Paris Agreement. No surprise, we need to decarbonize our power systems, shift away from fossil fuels, and shift towards clean, renewable and nuclear energy by the midpoint of the century in order to decarbonize the energy system. So that trend is fully underway. Renewable costs are coming down, deployments are going up, and it presents some synergies for industry as well. The industry sector, by adopting more electro technologies, can help through demand response and other measures to help bring more renewables onto the grid. But on the right side of the graph are some of the factors that are also coming into play for industry. Now that we're looking at a well below 2 degree temperature target, there's finally a lot of attention being placed on the industrial sector, which frankly hadn't been the case pre-Paris Agreement. The world is recognizing we can't reach net zero without massive decarbonization of industry. And in response, a lot of companies are committing to decarbonization targets. Many of them are pursuing science-based targets, and there's a real urgency for industry to act. And the little wedge diagram you see on the right-hand side is the IEA's ETP B2DS plan for the global industrial sector. And as you can see by looking at that graph, energy efficiency will clearly play an important role in decarbonizing industry, but there's lots and lots of CCS, and most decarbonization scenarios for industry currently have to include a lot of CCS. It's an important solution, but I think many of us recognize it's not happening fast enough. And so we really need to turn to some other near-term solutions like electric technologies in order to, begin decarbonizing much faster. We can't wait for CCS to happen in the near term. We've got to start moving. And so what can we do to start accelerating these electro technologies? This is where I think the report makes a lot of great contributions, because it lays out some recommendations for how to move the needle on these technologies. And for me, what I wanted to highlight were three important ones that I've seen by working with industry over the years when it comes to electro technologies. So we have to ask ourselves, if many of these technologies have already been available for many years, why haven't they been adopted? And what can we do to accelerate that adoption? Well, I've called out three primary areas, drawing on recommendations from the report. The first is we need to really start overcoming some knowledge barriers in the industrial sector. Well, what does that mean? A lot of small firms don't have energy managers. They're not researching new technologies. They don't have access to the right information to make sense of these technologies. So there are a lot of recommendations for government agencies and utilities to produce case studies, provide incentives, reduce these knowledge barriers, so they're at least on the table for planned investment projects where they may not have been in the past, especially for smaller firms. The second key aspect is with any new or newish technology, there's always some perceived risk that needs to be addressed. So how can that be overcome? Well, the report and other ACEEE work on this topic has made some recommendations, demonstrations and pilots, new case studies, information sharing among firms can help reduce some of those perceived risk barriers. And then finally, as Todd mentioned, and as Ed mentioned in his introductory slides, the financial value proposition is really important for electro technologies, and there are many co-benefits to electro technologies that remain to be quantified, I think, consistently. So how do we amplify and quantify those co-benefits? So with many of these electro technologies, we not only get a decarbonized process energy source, but also improve productivity, reduce pollution on site. Sometimes the technologies are simpler. Sometimes they don't require dedicated staff. And I have, like a boiler would, a coal or natural gas fired boiler may require a full-time operator. I've highlighted the case of an electrode boiler. This is one technology that's in hand. Some plants are already using it. And it brings a lot of these important co-benefits that if we factor them into the value proposition, suddenly these technologies become much more financially attractive. And that's an important part of, I think, accelerating their deployment in the market is let's start highlighting more of these co-benefits. And with that, I'll stop. And I think Colin is up next, but I'll turn it back to you, Neil.
Thanks so much, Eric. And turning it over to Colin for some concluding remarks, and then we will start some questions. And thank you, folks, for sending questions in. We're queuing them up, and we will discuss those after Colin's presentation. Thank you.
All right. Thanks, Neil. Definitely appreciate the opportunity to join the discussion, and I was really, really excited to see the report coming out. So I did want to take an opportunity to dig a bit deeper into what electrification might mean for industrial process heat. And so when I talk about process heat, I'm talking about energy used in kilns and furnaces, as well as boilers and combined heat and power. In many ways, the next phase of industrial electrification will be about electrifying heat, just because process heat is such a big portion of manufacturing energy use, and only a little bit of that energy is currently electrified. As Ed showed in a previous slide, the temperature requirements vary quite a bit by industry. This is where it becomes important to focus on the makeup and characteristics of an industrial sector. For instance, in the US, we have a much higher proportion of our energy used in the chemicals and refining industries, and overall, I think we have a much higher proportion of lower temperature industrial heat demand than the global average. So some of the recent analysis coming out of the National Renewable Energy Lab indicates that about 2/3 of industrial process heat demand is for process temperatures of about 300 degrees Celsius or less. So it turns out that a lot of our industrial energy use ends up being about combusting a fuel to make hot water or steam. There we go. Another point about these low temperature demands, is that they're a part of many different industries, big and small, across the country. Boilers really are cross-cutting technologies. So providing hot water and steam would seem to be big opportunities for electrification with technologies like industrial heat pumps or maybe electro boilers. If you look internationally, you see a lot of interest in industrial heat pumps. They can operate with coefficients of performance greater than 4. Research and development efforts continue to raise their temperature limits for those high temperature heat pumps, as Ed mentioned. They do require something like a waste heat source to get a reasonable coefficient of performance, though. So on one hand, you have these ubiquitous demands for hot water and steam in industry, which again makes it seem like great electrification opportunities. But on the other hand, I think the reasons to electrify these demands are generally less attractive than maybe for other electrification opportunities. And I think it comes down to the fact that it's more difficult to tie these technologies to increase productivity and profitability for industries. Getting back to this, I would say probably pretty common thread about co-benefits and everything. Eric did point out some co-benefits of an electrode boiler. But from what I understand, industry, when adopting a new technology, at least initially, pays most attention to the technologies that are known to increase productivity and profitability. But maybe on the third hand, this opens the door for thinking more closely about how steam and hot water is being used. For example, instead of using steam to provide the heat to dry a product, maybe you can directly heat the product with radio frequency drying, which may also improve the quality of the product. I think in the report there is a general discussion about a replacement of a steam boiler with electric heating technology, which was instructive. So in closing, even with these low temperature demands for process heat, electrifying industry isn't necessarily straightforward, which seems to be a general challenge for industry. Eric mentioned this concept of heterogeneity, which is definitely something, definitely a thing for industry.
Thank you so much, Colin. And now we're going to open it up to some questions. Thank you, folks, who've been pushing some of the questions in. Wanted to start out with a question that came in back in the 1980s and early 90s, before the electric power sector restructuring. Many utilities set up labs and testing facilities promoting electrode technologies. What changed? Is climate change the only driver? I know that I was one of the directors of one of those labs in the late 80s and early 90s. And as Ed has noted, this is not new technologies, but what's changed? Ed, Eric, Colin, Todd? Ed?
I'll volunteer to start on that, and then certainly others can chime in. Certainly, climate change and the focus on that is one of the things that has changed. I think another thing that has changed is the opportunities around digitization. These technologies more easy to control at this point, to pull the information, to use that information and turn it into wisdom, and to relate it to increased performance of these electric technologies. I think that's one thing that's dramatically changed in the last 40 years. Others?
I would say also there's a lot more transparency and pressure on the industrial sector these days when it comes to their current emissions, their current energy use, and where they need to go in order to address climate change. So a lot of companies are now reporting, for example, to the Carbon Disclosure Project. A lot of companies have targets for decarbonization, and electro technologies are one of the technology classes, some of which could be considered low-hanging fruit because they have been around for a while. And there's a lot of movement towards renewable electricity on the supply side. So it's a confluence of those factors that I think really makes for an important, moment in time for electro technologies to seize.
Yeah,
that didn't exist 30 years ago.
and consumers are demanding it, and so they need to companies need to address the consumer demand. Industrial facilities are those corporations are being leaders, and it follows through the whole supply chain. So that's, I think, has dramatically changed over the years.
Colin, any comments?
No, I think all the main points were touched on for me. Yeah.
I would just add that I think the capabilities of those electric technologies have continued to evolve as well. And there has been now more understanding of the mid-range process heat, for example, is now accessible with heat pumps that may not have been accessible 40 years ago.
Another question that came in is, are there opportunities to link renewable oversupply periods with industrial energy needs? And if so, what industries or processes are particularly well suited to that application?
I'll start on that and, of course, invite others to chime in. Where excess low-carbon energy is available, industry can use it in several different ways. One way is to use it for intermittent processes, or processes which can be run in intermittent mode. For example, in cement, clinker can be produced and stockpiled, stored until it's ready for later stages. That can be done with an intermittent source. There are other capabilities such as water purification in industry that can be done, generation of hydrogen and other chemicals that might be produced via electrode technology, of course, is something that industry has done for years. For example, consider chlorine. But I think there also is an awakening in industry that there may be a viable economic resource here that should get greater attention. And when we've recently talked at a industrial decarbonization roadmap, this realization kind of came out. A number of folks discussed it and said, well, maybe we should learn to run in intermittent mode more so we can take advantage of this. But I think there's also an understanding that storage, energy storage, is an important piece of the puzzle. And not only energy storage, but thermal storage as well. And of course, there are a variety of storage mechanisms other than just battery storage. Others?
Yeah, I would just add that, or maybe echo that there's certainly a lot of pieces that need to be sort of figured out for industry that maybe are a little more complicated than other sectors that have been thinking about this more for a longer time. But certainly it does seem to be some understudied potential for shifting production and thinking more about new ways to integrate industry and industrial processes into the grid.
Mm-hmm. We've seen some examples of, for example, not to use electric boilers too often as a key example, but of industrial plants that have multiple boilers running in parallel, electrifying some of them, and then running the electric boilers when there are favorable electricity rates, which could also be a design mechanism for a grid incentive if there's excess capacity from renewables. But the key is having that flexibility really comes with electrifying utility and end-use processes within the plant. And when that happens, there are many opportunities that Colin said need to be further studied that could present themselves for industry being a resource for stabilizing the grid and expanding renewable energy capacity.
So we have several questions related to the sort of the electric boilers. One of the questions that came in was, have we looked at the questions of both solar thermal process heating as well as the use of heat pumps for preheating of industrial boilers? So I know, Eric, you've done some work in the solar area.
Perhaps I'll just answer very quickly. Colin and I are collaborating on a project now trying to quantify those potentials within the country for different manufacturing industries and in different locations. And both of those opportunities you mentioned are really important ones. So heat pumps are a really well-proven, cost-effective way of either recovering waste heat or using ambient heat for preheating of boiler feed water and process air. And we're finding that there's significant potential there. And if you can couple that with renewable electricity, so much the better. That's the real key for electric technologies. But perhaps, Colin, you want to say more about the other work going on?
Yeah, I mean, I feel like we maybe in the energy analysis community, more specifically the industrial energy analysis community, are getting to a point now where we can start really diving into these questions. So more geographically specific questions about solar resources, how they might be connected to industry, either through solar thermal or even PV. I mean, I think it's just yeah. I think we're just now starting to be able to more thoroughly dig into those questions, and certainly we'll have some initial answers here hopefully in the next year by the end of the year. But yeah, I mean, it could be a very big opportunity space.
Well, and just to build on Eric's comment there relative to energy helping with demand response, industry already has large percentage of combined heat and power. And that combined heat and power is being used for distributed generation as a backup, as a buffer. I'm not sure, there's a number of words that you would use there, but that resource is being used to help in that regard. Other thing I'll note relative to distributed sources is that distributed steam and distributed thermal supply is something that can be used now rather than a large centralized steam system, which has been the common thing for decades. Now there are micro steam generators that can be used at remote locations in a plant that allow one to avoid sending pipes all over the plant and doing the maintenance associated with that.
Another question that came in was, and this came from during Eric's remarks, that electric technologies may not require the same number of operators as we saw for legacy technologies. So what may be good for decarbonization, may be good for the company, may not necessarily be good for employment. So does anybody want to touch the idea of questions about impacts of electrification on manufacturing jobs?
I'll start on that and say that from my experience in industry, when there's a shift of technology that frees up resources, there's enough demand for those resources that they are deployed elsewhere, where they can make value in another way. So although there may be less dependency on boiler operators, people that run the permits, I think the folks that generally would do that work would be very easily found to contribute in other ways. I think the idea of just transitions, equitable transitions are important in this space. Also, training of the workforce for the future is a really important aspect of this transformation as well.
Yeah, and this is Todd. I think that's a critical point that we continue to train, as the mentioned in the report, and each of the presenters talked about the digitization of technology requires more skills. So we need to develop our workforce to address that. I think that's just be a shift in terms of the skill set.
Another question that came in is, as we look at decarbonizing industry, Does this potentially offer a competitive edge for U.S. manufacturing in the future?
Well, it certainly does. And it's certainly important that U.S. industry jump onto this opportunity because industry elsewhere is pursuing this opportunity to be competitive then in a low carbon world. Industry will need to be able to compete in this area. So many of the large companies, of course, are international, and they're seeing even greater pressure elsewhere, which is part of the reason why they're looking to decarbonize here. I think they understand that technology is evolving. Market expectations, as Todd mentioned, customer expectations are evolving quickly. And I think it is vital for companies to compete in this space. And as we mentioned earlier with the non-energy benefits, these improvements in beneficial electrification and other technologies can provide value return that's important for industry to capture.
I would just add on the market side, there are increasingly more mechanisms that are holding industry accountable for its emissions and incentivizing low carbon products. One movement that's underway now is to try to label or at least measure the carbon intensity of building materials. So low carbon cement, low carbon steel, that could be specified by architects or local planners. So in that respect, investing in technologies that will reduce the carbon intensity of whatever output is produced by your industry, I think is a smart move in light of some of the consumer, market demand forces and eco labels and other specifications that are arising that are looking for low carbon products in the marketplace. And those don't have to necessarily come from the U.S., from a label perspective, but they should. So what it means is, U.S. companies moving first could have an advantage as those mechanisms take hold.
Yeah, and we're seeing that in New York, where companies, like just the cement, the forestry area, wood, can they make those low carbon products, and can they make it, in the U.S. and that's a critical point.
So, sort of related to the last question is: does electrification of industry allow for more locational flexibility and the potential for reshoring of manufacturing in the United States?
I would start with it definitely provides potential for more localization, but it's somewhat dependent on the availability of that electricity. And as we note in the report, the availability of the electricity being low carbon. If you look at the distribution of low carbon energy in the U.S., it's also very spotty at this point. So as we think about making things less concentrated in some ways, it still may be somewhat dependent on the locality of the low carbon sources. And that will be something that will change depending on where you are in the U.S. In some areas, electricity could be generated from renewables, wind and solar. Other cases, it might be from biofuels. So I think location does matter. Does it help with reshoring of portions of the capacity? It could. And that could be something of a great benefit to us. We've certainly seen in the impacts of COVID to a supply chain that there are needs for reconsideration of how to make the supply chains resilient. Electrification and the generation of that low carbon electricity could be part of that story. Others?
Yeah, I was recently asked a similar question from an international colleague who was wondering if there could be some analogous lessons learned from the unconventional shale revolution in the country. So we're building new crackers in new places that didn't have crackers before. Could that also happen in a highly electrified industrial electrification future as well. So I think there are a lot of pieces to that puzzle as well. But I don't think it's out of the question with those low cost, low carbon electricity sources.
I think also, if you look at it just down the road, what are the technologies that get developed, and that could lead for opportunities for companies to invest, in the United States to build here and manufacture it locally. The next stage of more high temperature heat pumps, for instance. That could occur right within the states.
One of the questions we've had several questions come in, all related to sort of the same topic, which is what is the role of energy efficiency, and how does energy efficiency and electrification come together in industrial facilities?
As you'll see in the report, we considered that question. And note that many of the emerging electric technologies, and certainly the transformative ones, are going to come in to be fairly expensive. One of the things that energy efficiency and materials management, that is circular economy, recycling, waste management, can do is decrease the burden, the energy burden, the cost burden for those emerging and transformative technologies. And as Eric noted, many of the electric technologies have been around for decades. Hence, energy efficiency and optimization of how that equipment is deployed could have a large impact in the economics. It's also important to consider the whole systems approach here, in that optimization needs to be not at the component level per se, but at the whole systems perspective.
Mm-hmm. I would say that there are examples of electro technologies that are more efficient than their conventional counterparts. One classic example is RF or microwave heating for drying purposes, because you're applying the energy directly to the working medium. And in combustion systems, you will generally have flue gas losses or shell losses and so forth. So there is a big efficiency argument for many electro technologies. The other piece of the puzzle is when electrifying, any new big project, it's an opportunity to take a step back and also look at the efficiency of the broader system, as Ed mentioned. So it's another message we try to put out is, with electrification of core unit processes, and the investments that go along with those projects, it often makes sense to revisit the efficiency of the system surrounding those technologies, because if you can reduce the amount of energy needed for a process that you'll then electrify, you may end up spending less overall than continuing with the conventional route. So there are two aspects to that efficiency equation.
Yeah, we always say, in terms of, renewable energy is great, but size it appropriately. First step, take a look at what efficiencies you can do. Do you really have to, generate that kilowatt hour? Is that needed in terms of that, or that,
Yeah, the IEA refers to efficiency as the first fuel, the first strategy, a message that ACEEE has been bringing out for years. So it's good. Yeah, good to hear that reinforcement, Todd.
Thanks for the shout out there, Eric. Several questions have come in about the whole matching of renewables to industrial electric loads, and how do we balance that and not create issues for the grid, for the utility, and for the facility in terms of reliability?
So I could start a little.
Yeah, go ahead, Todd.
And you mentioned, I think, as we developed, energy storage, other technologies that are coming up that are newer, coupled, energy storage coupled with renewable energy will be, a critical solution to help address that, that situation.
I think we also see the demand response capabilities of industry. Particularly, we see them when there's a problem. So I had, before moving to ACEEE, been in Michigan. And during February, or maybe it was in January a couple of years ago, there was one of these polar vortexes. There was a fire at an energy producing plant that moves natural gas, and hence the demand was critical in Michigan to meet the ability for residences and businesses to have natural gas. Industry dialed things back. They could do the same thing with electricity. Hence, I think the demand response component for industry is also an area probably a bit underappreciated.
One of the questions, we've had several questions come in around the whole question of the non-energy benefits associated with electric technologies. How well have those been quantified, and what needs to be done to better quantify those non-energy benefits?
I would say to begin with that they have not been quantified very well at all. There's very few case studies that describe the non-energy benefits. That creates a real problem for people in industry that look to justify that technology. They just don't have a fair basis to compare versus the incumbent technology. What needs to change is greater communication. I think pilots and demos are a route to put out reliable information that is pre-commercial, and that will help in many instances.
Yeah, I would second those thoughts from Ed. Oh, sorry.
No, go ahead.
I would just second those thoughts from Ed. While there have been a few case studies and studies on these non-energy benefits, we have much more qualitative information, meaning we hear about, a benefit being reduced air permitting costs or reduced pollution abatement costs, or maybe lower labor costs, or increased productivity. It's really rare to find, cohesive case studies in the literature that one can look at and say, well, this worked for my plant. So that is really a challenge, I think, put on the research community, the DOE, utilities. Best practice sharing with quantification of these code benefits is really important for getting the word out, and I think convincing other adopters that they're real and they're significant and they can really make a difference in your project investment calculus.
And it's going to take industry leaders because we have to balance the intellectual property and disclosure of somebody's secret sauce to potentially their competitors. But it'll take an industry leader who wants to step forward and showcase look at what we have done, and to that exact point broadcast that and disseminate that information out.
So a series of questions that are all related to each other. One of the attendees noted that back in the 1980s and 90s, the EPRI and other groups ran institutes that looked at addressing some of these questions with a focus on that. There were also questions about what's needed to accelerate adoption. These are not new technologies. If they're new and they're compelling, why aren't they being used? So, and then questions about what are the roles of government, and particularly groups like DOE in terms of research to advance this, and what policies and programs might be implemented to accelerate the adoption of electric technologies.
We talked earlier in the webinar about the drivers for adoption that are different than perhaps 20, 30, 40 years ago. I think that's part of the impetus for looking at increased adoption. In the report, we talk about several of the challenges that have slowed adoption rates, but we also point out areas where there are islands of adoption. For example, the microwaves of the surface treating, or some of the low temperature specific heating that have been really important. So I think that's part of the areas where we can see increased adoption. Some of the roles for the agencies are also described in the report. I think making public some of those non-energy benefits and quantifying them where possible through pilots and demonstrations that are funded in part by agencies is part of the route forward. Others?
Yeah. Anywhere we can showcase risk reduction, to the industrial facilities, they're there to make a product, make a profit. That we can have those case studies or those leaders willing to implement the newer technologies and showcase that would be beneficial. I think that risk reduction is critical, and investing more in terms of those technologies that are not yet here yet, and those solutions for those higher heat process loads.
I'll also note that as you dive into research areas such as we did for electrification, you uncover opportunities for additional research. And I think we'd like to hear from the community, certainly those on the phone, what might be the most impactful areas for additional research in this space. So if you have some particular thoughts there, feel free to reach out and suggest those to us.
Well, on that note, I think we're going to have to conclude. I want to say thank you to our panelists. Appreciate them being here. To my colleague Ed Ryder for leading this research. And again, thanks to all of the sponsors of the research project here, Tempest Advisors, NYSERDA, ComEd, National Grid, PG&E, and Southern California Edison. And we thank all of you for joining. We will be sending out a PDF version of the slides to everybody, and this has been recorded, so will be available, and we'll be sending that link out in the near future. And to everybody, again, thank you for your participation, and please feel free to reach out to Ed or myself with additional questions, and I apologize for not being able to get to all the questions. We had wonderful attendance, and we appreciate everybody's interest. So hope everybody's well. Take care. Be safe. Thanks. Have a great day.